Yes, hello friends, welcome back to George and Whitney tutorial. In this video we are going to look at the thermodynamic processes. So basically under thermodynamics we have different processes. So the first process we shall look at, we have the isothermal. We have isobaric, we have isochoric, we have what else? Some isobaric, isochoric, we have the cyclic, we also have adiabatic, and others. So we have the reversible, and irreversible. So all those are thermodynamics processes. So under when you're examining these processes, we basically make use of the what we call the ideal gas equation, which is given by PV is equal to nRT. So instead of N, it can be written as PV is equal to mRT, where P is the pressure, V is the volume, then M is the mass of gas. So this equation applies to only gases, so that is why it's called the ideal gas equation. Only applies to gases. Then R is the gas constant, which is given by, that's 8.314 kilojoules per mole. Then we have T, which is the what? The temperature. So that is the ideal gas equation. So basically when you're looking at these processes, we make use of that. So basically, without wasting time, we can start with the what? The isothermal process. So we have what we call the isothermal process. Now when we talk about an isothermal process is where so under this process the system is the system is at the same temperature with the what? With the surrounding. So they are in thermal equilibrium. So basically under this, so they are what? So temperature is constant. So temperature is constant, or change in temperature is equal to what? 0. Now whenever you're using temperature is constant, you cannot say that change in temperature is constant. It is wrong to say that change in temperature is constant. That's wrong. So change in temperature is 0, then temperature is constant. So when you want to say temperature is constant, when you want to say something is constant, then you say temperature is constant. You cannot say that the change, don't put change, you get? Now that is that is the process where temperature remains what? Remains constant. That means any temperature remains constant. So when we are examining this, we mainly use 3 properties, that is pressure, volume, and temperature. So those are the 3 properties in this equation, PVT, because N and R are constant. So whenever temperature is constant, that means pressure and volume are what? Are changing. That means Now, which law applies to pressure and volume? So this isothermal process is also known as the what? The Boyle's law. Is also known as the Boyle's law. So Boyle's law says that pressure is inversely proportional to what? To volume at a constant temperature. Therefore, if we remove the proportionality sign and introduce a constant, we shall have P is equal to C over V. So that means our PV is equal to C. So this one, this law will apply to all what? Isothermal process. Whenever they say the process is isothermal, so PV is equal to constant. So this constant C can also be equal to the other part, nRT. nRT. Since N is a constant, R is a constant, and also temperature is a constant. So the whole of that can be what? Constant. So that is basically an isothermal process. Then under isothermal process, now when we use the first law, so since temperature is constant, so from first law of thermodynamics, we know that the change in Q is equal to change in internal energy plus change in what? Work done. Now that means, remember, internal energy depends on the what? On the temperature. When you increase the internal energy, when you increase temperature, the internal energy must increase. When you decrease the temperature, the internal energy is also what? Decreasing. Therefore, internal energy depends on the what? On temperature. Now, if temperature is constant, that means internal energy is also constant. If the change in temperature is 0, change in internal energy is what? Is 0. Therefore, for isothermal, change in U is what? 0. Therefore, the heat supplied to a system is only doing work to the surrounding. So the heat supplied is only used to do what? To do work. So that is the isothermal process. Then the next process we have is the isobaric. We have the isobaric process. So this process, so under this isobaric process, what do we mean by isobaric? So isobaric process means that pressure is what? Is constant. So that means the change in pressure is what? Is 0. So if pressure is constant, that means we have the three properties: pressure, volume, temperature. That means volume and the temperature are varying. You get that? Eh? So under this law is also known as which law? So that means under volume and temperature, this one is also known as the what? The Chelsea's law. Chelsea's law. So the Chelsea's law, under the Chelsea's law, volume is varying with what? Temperature, and they are proportional. So volume is proportional to temperature. So this implies that volume is equal to CT. That means volume over temperature is equal to what? A constant. So where this constant is equal to what? So this is basically the what? The isobaric process. So an isobaric process, pressure is constant. So pressure being constant, that means from the what? From the first law, we know that the Q is equal to what? The change in internal energy plus the what? The change in work done. You get that? So we shall modify the equation for work done, and you will, so basically this one will be like this. That is an isobaric process. So after looking at the isobaric process, so we can go on and look at what we call So we have finished the isothermal, isobaric, so we are going to the isochoric. So we are going to the isochoric. Choric process. So now under isochoric, under this law, this isochoric process, the isochoric process means that volume is what? It's constant. That means what is varying? That means the change in volume is what? Is zero. So under isochoric, what is changing? Since volume is constant, that means pressure and temperature are varying. And you know temperature and pressure, they are directly proportional. Therefore, this law is also known as, this process is also now known as the what? The pressure law. So that means pressure is proportional to what? To temperature. That means you have your P is equal to what? CT. Therefore, your P over T is equal to C. You've seen that? So, now from the first law, we know that the heat supplied is equal to change in internal energy plus the change in work done. Now, for constant volume, for change in volume is equal to 0, work done will also be what? 0. Therefore, the Q, the heat supplied, is used to increase only the what? The internal energy of that system. So we shall prove this. This one we shall prove it later. We shall prove it in our next video. So basically, at first you have to know this. Then in our next videos we shall prove this. So we are done with the isochoric. Then have the cyclic, adiabatic. So before I go to the cyclic, let me first deal with the adiabatic. Now, when you talk about the adiabatic, process. Now, an adiabatic process, a process. So under the processes, I'm going to add what we call the polytropic process. That is another process. So under adiabatic, now another name for adiabatic process is called isentropic. So you can find, they can bring adiabatic instead of what? Isentropic. So that is another name. So under a process is said to be adiabatic when it follows this law: PV gamma is equal to a constant. So whenever they talk about a process as being isentropic or adiabatic, then it must obey this relationship, which is PV gamma is equal to C. So this relationship is derived, though we are not going to derive. So the best thing you have to know is that whenever they talk about an adiabatic process, PV gamma is equal to a constant. You get that? Where gamma is what we call adiabatic ratio, the adiabatic index, or the isentropic ratio, or isentropic ratio. So the gamma is given by Cp by Cv, where Cp is the molar heat capacity at constant pressure. Then Cv is the molar heat capacity at constant volume. So we shall also look at them in detail. So Cp over Cv, that ratio is given by what? By gamma. Basically we have that is the anidiabatic process. Anidiabatic process must obey this. So you can say if you have pressure 1, so it can be P1 V1 gamma is equal to P2 V2 gamma, which is equal to a constant, or it can be equal to P3 V3, like that. Then we can look at the polytropic process. The polytropic process. Now, a process is said to be polytropic. Now, basically, a polytropic process is a process that generalizes all the processes. You have seen the isothermal, isobaric, isochoric, the adiabatic. So it is given by this relation. So PV power n is equal to C. You get that? So PV power n is equal to C, where n is just a number, a whole number. Okay, it is a value. It can be any constant, 2, 1.5, like that. Now, if your n is equal to 1, so you will have PV is equal to C, right? Now, this law is which one? This one is the isothermal. This one was our isothermal process. Are you seeing that? Now, if your n is equal to, let me say, 0. So v to power 0, you have 1. So you have P is equal to C. That means P is constant. So from which law is P being constant? That is the isobaric process. So from the isobaric process, we said pressure is constant, which is the P. That is what? That is constant. Therefore, that one will give us what we call the Chelsea's law, the isobaric process. You've seen that? So where n, so n is basically called the polytropic index. Seen that? So basically a polytropic process generalizes all the laws. Then after that we can look at the cyclic. So cyclic process. So a cyclic process, a process is said to be cyclic. For example, if I have body is coming from, I have state A going to state B. If you have state B here, and I can come back to state B through another process like this. So the process is going to go like this and comes back. So the process is in a circle. So that process is called cyclic. So cyclic process is where a system is changed from state A to B and comes again to A through another what? Another process, through another state. You get that? So this is a cyclic. So it can also be from A to B to C. So you can come from A to B, then B you go to C, then from C again you go back to A, like this. So when the process is like this, it is in a circle. Are you getting that? Now that is what we call a cyclic, and work done in a cyclic process is 0. So work done in a cyclic process is 0. So the work done is equal to 0 in a cyclic process. You get that? Then after the cyclic process, we have what we call the reversible and the irreversible process. Now, a reversible process is basically a process that can go back to its original state by just changing the conditions that caused it to go in that state. For example, if you have from state A and you go to B, so from A to B, going from here up to here, you have gone through what? Some process. You see? Now, if this body, if this system at state B can be brought back to A by changing in the position, in the factors that caused it to come from A to B, but in the same line, but same conditions, then that process is said to be reversible. You get that? Hope you're getting that. So a reversible process, if it can go back but to the original state, if initially it was at A and it comes to B, then coming it from B to A but in the same path, then that process is said to be what? Reversible. But if now when you look at the cyclic, yes, can go back to its original state, but not along the same what? The same path. So in the reversible process, it must take the same conditions as in the reverse direction. The condition should be what? The same. Now, if it takes the same condition, so an irreversible process is one that cannot go back to its original position. You get that? By changing in this condition that caused it. If it comes from A to B, and when you apply the condition and it cannot go back to A, then it is said to be what? Irreversible. So thank you for watching. Don't forget to subscribe and share the video. Thank you.